Many research studies have provided promising evidence that head-mounted display augmented reality could be useful in orthopedic procedures and intraoperative guidance. These systems can potentially provide better accuracy in positioning and decrease radiation and time. However, it's important to explore specific design requirements and guidelines for these systems to better integrate them with actual operating rooms. In this project, we conducted semi-structured interviews with 3 experts, including 1 orthopedic trauma surgeon and 2 radiologic technologists, all familiar with AR. Each interview consisted of 2 parts. First, we asked participants questions about several angles of the research problem. Second, we shared 3 storyboards generated based on previous studies and asked participants about their specific implications. Findings show that participants envision adopting HMD AR systems in 3 main categories: surgical interventions, C-arm positioning, and collaborations and interactions. We further analyzed the data from multiple perspectives and identified requirements of operating rooms and guidelines for design or selection of HMD as well as design of AR system. Sufficient technical specifications, sterilizability, fog and sweat resistance, and allowance to use certain add-ons including plastic shields and corrective glasses are important in designer selection of the device. In addition, the device should have comfortability and preferably provide radiation protection. Also, our findings highlight certain consideration in the operating room, including moving parts, issues related to workflow, requirements of the stereo field, and physical obstacles, and finally, ambient audio and intense lighting in the field. In the end, we specified desired interface features for different aspects of AR system. According to participants, it's important to display movement-related information in addition to visual overlays. For instance, for C-arm positioning scenario, we can also have instructions on required angles and positions to move the C-arm. For interventions, providing analysis and annotations on medical images in addition to overlays could be helpful. We further highlighted that different user interactions and overlay adjustments could add more flexibility to the system. We highlighted important factors including tracking and markup placement, considering physical obstacles as well as possible command and feedback types. And we provided suggestions to enhance spatial awareness as well as integration with workflow. To conclude, we identified 3 potential domains for the use of HMD AR, highlighted requirements of operating rooms, and provided guidelines for these systems. We hope that this study would benefit future AR design works and make HMD AR closer to clinical use.